Hi everyone, this question is given the function of f and g as follow. So fx is a quadratic function, gx is a surd function. For the first question, state the domain and range for the f and gx. So domain will refer our special case here DSLR where we need to calculate the x, range of x. Then range, we are going to find our special case function which is cursor. So start with the domain of the function fx. Quadratic in the domain is not a special case, so it will be negative infinity up to infinity, so no need to calculate anything. But for the range of the quadratic function here, it is a special case, so we will close the quadratic characteristic here. We can see the value out here is 1. Then the quadratic that I close here is a positive coefficient, so it means 1 to positive infinity. And this one will be minimum value of the quadratic, so it will be close bracket to indicate that this value is included. Then when we move on to domain from the function gx, surd. Surd is a special case. We need to calculate under the surd will be more than equal 0 to define. So x will be more than equal to 1. So therefore, it will be 1 to infinity. Meanwhile, for range of the surd function is also a special case. So range, we just close and see what is the outside value. Outside value here is 0. And the surd function that I close here is positive coefficient. So it will be 0 up to positive infinity. And this 0 indicate this is the minimum value of this function. Then we move on to second part of the question where we need to calculate the composite function fgx and gfx. Some more is fgf. So we calculate for this first, substitute the gx surd into the function of f. So this x will be replaced by the function of square root. And we have square root and square. We can simplify to get x minus 1 plus 1, so we get x. Meanwhile, for gx, we substitute our fx here is square root plus 1. And then this surd function will be, this quadratic function in the bracket will be represented in the surd here, substitute in the surd here. So x squared plus 1 minus 1. So plus 1 minus 1 cancel off. Then square root and square, we can get x. So finally, gfx, so we don't need to calculate again as gfx here mapping back to x. So lastly, we just need to find fx only. So fx, it is equals to square root quadratic x squared plus 1. Then we move on to the question C. They ask us to draw the function of fx and the gx in the same axis, means in the same axis of Cartesian axis. So x-axis and y-axis. Draw the both function together in here. So for quadratic minimum value is 1. You can see quadratic ax squared, bx we don't have, so means it's symmetry at the y-axis here. The intercept here will be 1. So quadratic positively is a concave outward. So this is our fx equals to x squared plus 1. And then we continue. For the surd function, so surd function we have 4 directions, whether going to the right up or right down, and left up or left down. As we can see, we can read it from the domain and range. Domain 1 to infinity means this is going to the right from 1. Then 0 to infinity for range means it's going up and right. So this is the orientation for the graph, going up and going to the direction of the right. And what is the minimum point? We can see here x is 1 and 0. So coordinates start with 1, 0. So we find out our 1, 0 here, then shooting to the right and shooting to the right and shooting up. Then we label this is square root of x minus 1. And then state the domain of the f that need to be redefined so that it can be inverse of the g. So as you can see, FGF, GFX, when it composite, we get x. So here we can indicate that we know that the relationship between the fx and gx, they are inverse to each other. But the problem is now you can see the quadratic here is not one-to-one function. So when it's not one-to-one function means this quadratic cannot be inverse. Therefore, this question asks you to state the domain so that it can be the inverse of the g. Means you want to select the domain from this quadratic so that this domain can make this function one-to-one. So if you take the whole value or the whole piece of the quadratic, of course it will not be one-to-one. The only thing we can do is we're going to take half of it. So when we take half of it, you can see this is the gx, this is the fx. In the middle seems like have a reflection axis. So to inverse to get gx here, your domain, the domain of the fx, so that it can get the inverse of g function. It will be start from this half. So you can see this curve when you reflect as a inverse function graph. The pattern is here. So means our domain will start from 1 to infinity. Alright, so just a typo. It's not, I not mean 1, this is 0. 0 because here is 0. So I want this side. Start from here x 0 to infinity, the whole graph at the right hand side here.